Hi, I'm Brendan O'Mahony from Broma Engineering, and this is episode 1 of the Data Center Equipment series, and we're starting with MV Switchgear. Okay, just to start, I'm not an expert on MV Switchgear, I'm not an electrical engineer, but this is how we manage equipment in general, and then there's a few bits and pieces you need to know about MV Switchgear in particular. So anyway, what is MV Switchgear? It's medium voltage switchgear, so that's usually it's around 20,000 kilovolts, that's 1000 volts, so 22,000 volts. That means it's more dangerous than low voltage. The arc can jump much further, and that means the switchgear needs to be designed differently. So MV switchgear will be coming, it's the first piece of equipment that will be on our systems. So you have your utility, and then you have a border, you'll have a MV cable into your MV switch room, MVSR. This can be anywhere in the site really, but it's usually a dedicated room. It can be also inside the building, which you have in some data centers. Sometimes it's outside the building in its own dedicated room. Sometimes it's part of another building, but find it on your drawing. Make sure you identify it early. It's very important that the MV switch room is ready on time. So we're going to have usually these are OFCI, not always, but usually. They can be CFCI. There's other videos explaining what those mean. Owner furnished, contractor installed, contractor furnished, contractor installed. So the owner is buying this stuff. So it's usually already designed and ordered before you arrive if you're a commissioning manager. Now, what we need to do is get the switchgear in here. These are all cabinets with switches. Now, some things you need to know, sometimes there's blast duct needed, sometimes there isn't. It's easier just to design it in and make sure it's there, it's safer. If there is a arc explosion, that force goes up, out and outside the building. There's usually a blast louver that blows up and doesn't hurt anyone outside if it does go off, and hopefully nobody's standing there anyway. Maybe there'd be an exclusion zone would be the perfect scenario. Nobody stands around that blast duct. So anyway, you're getting your utility is out here. I call it in Ireland we have the ESB, in every country they have a different name, and they will be building a substation, or they'll be supplying the substation with high voltage. Now, I don't want to get too much into this, but outside here there'll be a transformer which is HV to MV. And then this is where the confusion starts. Who's taking care of this cable? So this will be MV cable, and we need to do the roles and responsibilities. Who is going to do what here? Immediately get onto that. It'll take a while to trash it out, but put it on your list of risks and let everybody on the team know that we need to know who's doing what here. So with everything in commissioning and in data center management and any facility management, just think of everything as a black box. So what do we need coming into this box? In this case, it's quite simple because we just have MV power in, there's a switch, and we have MV power out. Now, it's not that simple in real life, but just to make it to its absolute basics. This can be going anywhere. It can be going to a transformer, straight into a transformer. So you want LV power, so you have a TX transformer. So you're going MV to LV. Or you might be going to a ring main. You have RMUs, ring main units. But don't worry about that, we'll get into that later on, okay? Right now we're going to focus on what you need to do to get this MV switchgear over the line. So you have to get this cable installed to wherever it's going, whether it's a transformer or more switchgear. Let's pretend it's a transformer to make it simple. This needs to be commissioned, this needs to be commissioned, and then this needs to be commissioned, the MV switchgear itself. The vendor, hopefully, has been contracted to commission the MV switchgear. So that's what you're managing. You don't need to know everything about MV switchgear. The vendor is doing it. Now, before this, you need to understand the delivery. How is it coming here? Who's lifting it off the truck? Where's your roll-in route? You need that all planned. The logistics team, I would make the logistics team do that. That's their job. So you just ask every week in your weekly meetings, which you should have on site. We need our roll-in route for MV Switchgear from the logistics team, and you will help them with it, but don't do it for them. That's their job. Otherwise you're going to get bogged down and you'll get nothing done. Delivery, get it off the truck. Here's the truck. Who's taking it off? It needs to be, you need to know from the client the Incoterms, and that means who's doing what when it comes to delivery. Is it being delivered to site? Is it curbside? Are they setting it in place themselves? Next step is we're setting it in place in the room, so you should have a layout drawing showing where that switchgear is in the room. Then a set out engineer, or you use augmented reality, or use a tape. You need to know where that switchgear is going. The vendor will expect you to have that marked out for them. Always be careful with this. Make sure you understand fully how it's being put in place. There might be a plinth or a chassis that needs to go in first. There might be ductwork underneath. It might be underneath fed. There might be ductwork going out. So get your 3D model. Make sure everything's in there. Check for all the services. So ductwork coming in. There should be pipes coming out of the ground. With that, it should be modelled, and this QA/QC should be done on that ductwork by the CSA crowd that installed it. And the floor should be finished. The floor should be painted or tiled or whatever they need to do. It could be an epoxy floor, but it should be a dust-proof environment by the time this stuff comes in. And that brings us to room ready. The room, you need to define from QA/QC point of view what room ready is for switchgear. So is the containment in? Is the lighting in? How much of the room is completed before that switchgear gets rolled into place? Okay, so we have the switchgear. We have it marked out in the room. The layout drawing is confirmed. These are issued for construction drawings. Make sure this is all done. So the drawings are issued for construction, IFC. Check with document control. Check with the CSA guys, your friends, your colleagues from CSA. Make sure everyone is on the same page. Room ready criteria is defined with the client. This is in a PEP, project execution plan. It's clearly defined and has been approved. So this is long before switchgear ever arrives. You know this. What does room ready mean? Okay, lights, containment, ducting, floor conditions, wall conditions. You'll need drawings on the wall. You might need them yet, but you will need them for power on. That's a requirement. You'll need your labeling done on cables. You'll need your cable testing done, so very low frequency testing, VLF testing will need to be done usually within 24 hours of turning it on. But let's go back to set in place. I'm getting ahead of myself, so set in place. Hopefully the vendor is doing this. If not, a heavy lift and shift crew will have to move it into place and very carefully get it through the roll-in route. I'd be much happier if the roll-in route was approved by the client. So sometimes there might be doors that are too small or walls that need to be left down all the way into where you're bringing this. So just be aware of door sizes. And then we're putting our switchgear. We'll just take one cabinet and we're setting it down where it's supposed to go. We usually just mark the corners, and always mark, if you're looking at plan, define whether you're marking the contact patch on the ground or you're marking the extreme outside. This can be confusing and it can make a mistake. So always remember that, like, when you're looking down on plan, is it the extreme outside corners or the contact patch? Because the contact patch can be smaller inside here. Just as a tip for you. Make sure that is defined. We always go extreme outside because it's easier to remember, but it won't exactly be the corner that's touching the ground or the plinth. Okay, that's set in place now. Everyone's happy. The room is clean. Now it's time for the vendor to start doing their installation process and for the electrical team to make sure that the cables are going in properly. So you're landing and terminating. You'll be taking them off again to do your VLF testing, and then you'll be ready for power on once your VLF test has been approved. Power on is quite a big deal for MV switchgear. It's usually the first time the power is coming to site. Big power is coming to site anyway, and people get nervous. So make a power on plan. and you should have a switching plan as well. Your site appointed person should be here to do the switching, and their team of appointed people. Your senior appointed person, I mean. So everyone gets very nervous when it comes to turning MV Switchgear on. So your senior appointed person needs to take control of this and make people feel calm. Your job as the commissioning manager will be to make people feel calm. Same with QA/QC. Everyone needs to be calm and write out, make a list of what we're doing. Number 1, 2, 3, how the power on day is going to look, and the evening before there'll be a power on meeting. Put it in the calendar early. Give the clients and all the stakeholders the feeling that you are in control of this, and then publish this power on list. We have them here. We'll give them to you freely from previous jobs we've done. There'll be no details of who the client is or anything, but it's generally the same for all MV switchgear. And you're bringing power to the switchgear. And if you're ready, you want to be bringing power from the switchgear through the transformer and into the main LV switchgear as soon as possible. I wouldn't start cascading power down. So cascading power means that we're bringing it from HV to MV to LV. It's better to do all this very quickly and be ready to take it, at least to the MV switchgear, and let the transformer soak. But we'll go through the transformer in the next episode. Okay, so we've had our power on meeting. We have walkie-talkies. You'll need walkie-talkies to communicate with everyone on site. Operations might be involved at this stage, depends on the project. They usually will. So the senior appointed person and his team is, or her team is the most important person on this process. So we're going to switch it on. Let's presume switching on goes well. The bus is now live inside in the MV switchgear, and there's live to all the outgoing switches. We'll talk about the site acceptance testing. A lot of this will be done before power on with MV switchgear because it's so dangerous, but you'll have to have your controls. You'll be testing everything that's needed from safety point of view. That'll be in your sequence of operations, which the client's design team will have put together and given to the vendor a long time ago. So now the vendor needs to prove that everything works in that switchgear. So they'll be turning it on and off a bit and checking faults. And making sure it does what it's supposed to do. So there'll be documentation and checklists that need to be filled out at level 2 and level 3. So the SAT is level 3. It's vendor will perform that as well, or a specialist they bring in. And then you've all your check sheets completed, and then you're ready for handover to commissioning, H2C. And then we're saying we are ready for level 4. So your CXA will be involved in all this as well, watching, making sure they're happy with what's happening, that the quality levels are up to standard. But all this needs to be planned well in advance. So level 0 is, and that's what we're doing now for a project, is we're getting all this ironed out, nailed down, submitted, try and get it approved from whoever's available at this stage. Obviously people will be reviewing it as they come into the project later on. But the sooner you can get all this down on paper and in a process, and we have them for you if you need them, we'll send them on to you. Send us an email. It's our project execution plans, PEP, for MV switchgear, or sometimes it's the MV system. So we're including the ring main unit, and get all those details in, get the check sheets agreed upon, get them approved. When the CXA arrives, then they'll be very confident that they have a commissioning team from the GC that know what they're doing, and every step of the way. It turns out to be quite a big document, but we'll send you on the ones we have, which will get you 80% of the way. You'll just be changing the details after that. So I hope this was useful. I know it's a bit clunky and a bit all over the place. We're just trying to dump them down. We'll come back in a few months and get these much smoother, but for now we're just trying to get them out there, get used to making videos. And the next one we're going to make is on the transformer. So the MV switchgear will go from go through the transformer, be turned into low voltage energy, electricity, and then it'll go into your main switchboard, which we'll talk about on the episode after transformers. So until next time, thanks for listening, and please leave comments or ask questions.